Video today we're going to talk about how you can find out which part should be your U piece when you are trying to do substitution by integration. I'd encourage you to pause throughout and here are sort of three situations that I would say are nice substitution by integration questions. So the first thing we're going to do when we determine what to make our U piece is we're going to pick our U piece so that it gives us a nicer question to answer. Here, if I make U 4x plus 1, it works nicely because the first thing that it does is it sort of makes this one here just a U value. So it makes the integration that I want to do a little bit easier. The next step that we're always going to do is we're always going to do this du dx step. I need to get everything in terms of U before I integrate. So that is a problem, this part here, for example, at the moment. I know there are other issues as well, but what you're going to see is if you handle the du dx first, it will often fix other things for you. So we're going to do 4 for this one here. Okay. In this one, what we're going to do next, so getting dx on its own is a good idea. So we are allowed to do stuff like this. Now, in this particular question, we're going to find that it won't have solved everything just yet. But if we just start kind of working the pieces together, it's going to become more apparent what we should do. So we could do something like this to start off with. Numbers can be brought together. So for example, this 2 and this quarter make a half, and that can be written at the front here. That then leaves me with this. Okay, so the only problem here is solving x. But sometimes, as you're going to see in the next video, the next example even, that problem isn't necessarily going to happen. So we always sort of do these steps first before, in this case, we need to find a way of getting rid of x. So if we go back to our first equation, we're going to rewrite it so that we get u minus 1. And then if we do a quarter of that, that would give us x. And this is our way to sort of make this slightly nicer to work with. The quarter, I'm going to put the quarter at the front with the half. We're going to have an eighth. And then that's going to leave me with, it's a u minus 1 times a u to the half du. We're almost finished. We can simplify instead a little bit as an eighth. And let's expand this bracket to the 3 over 2 minus u to the half. And we now have a situation where we're pretty much ready to integrate. Okay. We'll finish this one off. So over here, what we're going to do, we're going to leave the eighth. We're going to put our bracket here. So this would be 5 over 2. So it would be 2/5 u to the 5 over 2. Minus 2/3 u to the 3 over 2. Okay, final things is we would expand this out. We would put our u back in. We put our plus c. Okay, but that's not really the emphasis of this part right now. What we're trying to see is that our main steps are that we work through these ones here and we try and get it all in terms of the same letter. So let's do another one, and we're going to do 1 and 2. But 3, you're going to find that that step doesn't always take place. So here's our question. Let's start by making u equal to, let's go for 2t squared. So now when I do du dt, I will get 4t. So this time around, it's not just a number, it has some sort of value, some other variable in it as well. So let's see what we can do with this. So our first step might be something along the lines of that. That's using our substitution. Okay, so that would be from the first step. If we do some more work here with du dt, well, we know we need to get dt on its own. So if we try to do that, we will get something like this. Okay, now when we sub that in, you're going to see that something interesting is going to happen on this one. So this is all just the same as before. And now I have 1 over 4t du. Well, this gives you the opportunity to cancel these ones out. And then with a little bit of rewriting, I can turn this whole thing here into 1/4 the integral, and it is in fact just EU to the du. That's really, really nice because this bit here is really nice to integrate. So let's finish this one off. Let's do the whole question for this one. So this is going to give me 1/4. E to the u integrated is just e to the u. Okay, and then I have a plus c. Because I don't have limits, instead of e to the u, I'm going to write in what that actually is. So that's 2t squared. And if you quickly test this using the chain rule in your head, you will see that this in fact does work. 4t you get from the inner divided by 4 turns into a t, and the u part stays the same. One more time, let's have a go with it. So this one here, pause the video, think for yourself what would make sense for you. So here's what I would do. I would say u equals sine x, du dx equals cos x. If we begin substituting all of this in, we'll get something along the lines of sine, not sine, we replace sine. We'll get u to the power of 6 cos x dx. But then when we get the dx bit on its own, what we'll find is we'll get dx equals 1 over cos x du. So we're going to have, again, a situation where something cancels out. Let's try that now. U to the 6, cos x, and dx is going to be replaced now with 1 over cos x du. So this whole thing here is going to become integrating u to the power of 6 with respect to u. Turns into what? Turns into a 7th u to the 7 plus c, or if we undo it, it's 1/7 sine 7 to the x plus c. So what you've seen in this video is that step 1 and step 2 always need to be done. Sometimes there is an additional step there like step 3. If you sort of set your working out like here and you think, what can I make u to make these awkward parts easier? Okay, that can sort of guide you to how to do your substitution by integration.